Welcome. This is CIST1401 on March 21st, 2024. And we're going to try to record the class for those that can't be here today. I did want to just show the course schedule. We're getting very near the end. We're down here in week 11, risk management. So we're going to be talking about risk management today. We have covered all the technical concepts of networking. So now we're talking about some of the more business or management sides, if you will. I also wanted to point out several students ran into a problem with lab 9.1. I put an announcement in that you can go look at, but basically down here in step 4, it was missing 2 commands. They are in step 3 right above, so you can just see them up there. But if you read the announcement, it'll explain to you how to complete that lab when you get to it. If you haven't got to it yet, that's fine. I'm just mentioning it, so hopefully it'll save you frustration when you get there. Okay, Module 10, Risk Management. Risk management is a very broad category. We're talking today mostly about network and computer network risk management, but risk management really covers the whole process of identifying risks, assessing them, figuring out how to mitigate them, and what vulnerabilities you may have that could affect your network's availability and your data integrity. So today, today we're going to talk about identifying potential risks, which are often called known because you've identified them so you know they're real, assessing those potential risks, minimizing or mitigating those potential risks, and in some cases, this may even include taking out insurance policies. I've worked on projects where in order to share some of the cost or remove some potential cost burden, they'll get an insurance policy if something really goes wrong. Also part of risk management is monitoring for known and unknown. We call unknown risks novel or new. We didn't know about them, we didn't plan for them. And then responding when an incident occurs. Now, sometimes included in risk management is recovery using prepared plans, and then learning so that particular risk is not a problem again. So this is kind of what we're going to talk about today. And for those of you that just got here, I had a request to record by some students that couldn't make it. So unfortunately, these classrooms are not equipped to record just yet. So I've got this set up and we'll see how it does. Okay. So, I'm sorry? Oh, that's fine. Oh, that's fine. Yeah. So by the end of this module, we're going to be able to identify people, technology, and malware security risks. Hey, we're going to talk about ways to increase and improve our network security. We're going to talk about physical security briefly a little bit, but that is important. And we'll talk about some tools you might use to harden, and that means make your network more secure. And then we'll explain and talk a little bit about security policies. As I've said in the past, your biggest risks almost always are from your employees. That's just a fact. It's unfortunate. All right, so just some terminology before we get into this. The word hacker, everyone knows that from the movies. When that term came out, which was, I think, right around when I was born, probably, so long before I got into the field, it was a positive term. And it meant someone who spent a lot of their spare time playing around with technology, trying to get better and to really understand the industry, the intricacies of hardware or software. Now, of course, hacker is talking about an individual who gains unauthorized access to various systems. In the industry, we have 3 terms for defining different types of hackers. You can actually hire what they call white hat hackers, and these are the good guys, but they will come in and try to hack into your systems to see where the vulnerabilities are. And there's companies that you can pay to do that. You bring in experts, and they will try to get in. And of course, if they find weaknesses, they'll tell you about it. Black hat hatters are what you think of. These are the bad guys that are out there trying to steal. We often think of criminal organizations, but today a lot of them are ran by countries like China or Russia. So a lot of they have huge people over there. All they try and do is hack into companies and the government here in the U.S. And then there's another term that's not used as much, gray hat hackers. And these are people who generally are good people. They had been good people, but maybe something happens in their life, and now they engage in some illegal activity. And if you get a moment, I put some names down there. These are somewhat famous examples of people who hacked various things. And I think they're all in jail right now. Okay, so we're going to talk about some more terms. A vulnerability is a weakness in a system or a process. So Windows often releases security patches to patch vulnerabilities. An exploit is what a hacker would do to take advantage of that. And if Microsoft, for example, doesn't know there's a problem and a hacker is able to exploit it, we'll often call that a zero-day exploit or a zero-day attack. That's when someone uses that vulnerability before the experts even know it exists. And that does happen from time to time. They are malicious and they are intruders. These two these two graphs, I'll blow them up so you can read them a little bit better. Let's see, so this one is talking about cyber incidents. So this is for large businesses, what they consider global business risk. So down here they have things like fire, climate change, legislation. But you notice the number one of large corporations, their number one concern is a cyber incident where someone breaks in and steals their intellectual property or customer information or what have you. This one's also kind of interesting. It shows where some of these risks come from. And so you have, down here, people doing things they shouldn't do, misusing email. I knew a guy, he got fired, but he had a job at HP, and he also had a side business. Well, he would have his side business customers email him at his HP email, and then he'd make quotes and do all that. So you can't do that, right? That's abusing email. So, but up here, the number one, of course, is privilege abuse. So this is an internal user, someone who's authorized to use a system, but they do something they're not supposed to, and steal data or what have you. Okay, hopefully that's making some sense. And then just some more people risks, because not everyone who causes a problem is a bad person. A lot of times they fall to some sort of social engineering. And I describe these guys as sort of like used car salesmen. They just have a way of talking and speaking that tricks a lot of people, even good people, even smart people, especially engineering kind of people, because we're often not that emotionally intelligent. And they can use various methods to get in and trick you into doing something you normally wouldn't do, or even giving them your username and password so then they can log in as you. Over here it says the percentage of database breaches, so think of like a company's customer database, right? The percentage of database breaches that involve insider threats, 57%. So these are not external hackers. This is over half is somebody inside the company. So just be aware of that. Ooh, I don't know how I did that. That was magical. Okay. I'm getting better at the whiteboard. All right. And again, we're still talking about people, and mostly we're talking about your employees, and we call them, stop that. I'll stand over here. We call them insider threats because they're within your organization. And we'll get into that a little bit more in a minute. But they may have a malicious intent, right? Somebody gets promoted over them, or they get a pay cut, or their responsibilities change. Now they're angry and they want to do something. They may just do it inadvertently, right? We're all human. We all make mistakes. They can accidentally delete a database, accidentally take your website down for a while, right? Those things happen. Or, and this is rare, but it's in the movies, right? They get compromised. So someone has some dirt on them and forces them to do something that normally that person would never do. Some ways that big corporations or the government might do to prevent this is they'll do a background check. So to teach here, I had to have a background check done. I'm not sure what they did. It took them about a week because I'm old, I guess. Young guys, it probably wouldn't take that long. I don't know. Enforce the principle of least privilege. I think we've talked about this. We will hit on it again today. But I'm sure I've told you in my previous roles, I always had administrator rights on my company laptop. I could install anything, do anything I wanted. Here at the school, I don't. I'm just a user. I can't do anything. But that's the right way to run a business, right? You should not give every employee access to everything. You should give them access to what they need to do their job. It just prevents temptation and other things. Design checks and balances. That's very true in many accounting departments. One person will physically prepare checks and another person will sign them. So there's always at least two people involved, or some checks require multiple signatures. And then you can employ data loss prevention. These can often be systems that will sit on your network and they'll just watch for unusual traffic. If somebody starts streaming gigabytes of data out of your network to some unknown IP address, well, that might be something to worry about. There we go. So that was people. Now we're going to talk about technology. And most of these risks we're going to talk about right now are external to your company. And they generally fall under the idea of denial of service, DOS. So you've got a web server or an application server, maybe your Workday or ADP or some big company with lots of people coming to your site every day. And these technologies are going to attempt to bring your site down and make it unavailable to your users. And there's several different ways they do that. Distributed denial of service, and we will talk about that. Distributed reflection, that's the idea of if this is the evil computer, it's going to send a packet to your computer that's going to trick your computer to send a packet to the target. So it makes it harder for them to trace back to me. And then amplified using a simple trick. We'll talk about one of these to cause a lot of work on the server. So you send in a simple request and now the server is quite busy handling that simple request, and then you get thousands of computers to send in that simple request and they just overwhelm it. Those are the main types of denial of a service. Down here they've got a couple of others. Just permanent denial of service, that's when someone tries to upload new firmware perhaps on a router and damages it. And then friendly denial of service, that could be an accident. So if you remember the other day, we were talking about some network scanning tools, and I mentioned Nmap, which does network scanning. Well, if you got enough people to run it on the school network at the same time, you could cause problems. So, but it wouldn't be we were trying to take the school down. We were just playing with it. So, okay. There we go. This is an attempt to show internet-enabled or computer crime, we used to call it, but crimes that are not physical crimes. Nobody's going in with a gun. This is all happening on the internet. And there's all sorts of scams out there. But what they show, so these confidence scams, that's the quick talkers. And they're saying the number one scam is when someone is able to get in and compromise your email and pretend they're you and do something with that. So big dollar values out there, lots of people doing this, and it can cause real problems. Sometimes it's just nice to have some context around what we're talking about. So that's hopefully what that provides. Okay. Whoops. All right. So there's many different technology risks. Social engineering we've talked about. We haven't got to ransomware or malware. We will talk about those. We mentioned email phishing, insider threats. We've spent a fair amount of time on. And then we just talked about these denial of service attacks. And I shared this, well, one, so you could see there are many different ways. This slide over here, I'll go ahead and blow it up because it's not really readable. But it's meant to show, whoops, there you go. So it's showing traffic that's involved in denial of service attacks by country. And over here you can see the biggest one is China. So that might be bad guys, but it might also be the Chinese government. Switzerland was surprising. Turkey, maybe not. Brazil. But these are just probably more normal levels. Every country has some of this, but China has the vast majority.
Those, are you saying those the countries that have been attacked the most?
No, they're the ones that are generating the traffic. Right.
Why is Russia up there?
That's a very good point.
And North Korea.
Yeah, I don't see a date on this either. So, but just interesting.
Yes, I found it interesting that it's called CIST, that they've been hacked. Like they've been hacked and they left, like I say.
Yes. I was talking to somebody about this because in the old days you'd picture like 5 guys locked in a closet trying to hack into something. Now, like countries like China, they'll get thousands of people with PhDs in math, and they'll have an office, and that's all they do all day is try and hack into companies and countries over here. Here's some other different numbers. These I like to show both sides of the coin. So this one here says that for data breaches, so this is like when they steal your customers' information, that most of that happens by outsiders as opposed to internal. And I'm not sure how the percentages work. The 70 and 30 add up. The 55 is maybe saying that some large percentage of those outsiders are organized criminals, not just small groups. And then over here we have, malware, worms, we'll talk about phishing, data breaches, different types of cybercrime. And then this one over here, ranking of concerns for business owners. And so this will be in the slide deck. I will upload it. You're welcome to peruse it at your leisure. I throw some of these in to break up the slides. The slides tend to be very dry, so I figured this is at least a little interesting to look at and talk about. All right, so we're now going to talk about one type of denial of service attack. There are many. If you think back, in fact, I visited the class the day Dr. Walker was talking about TCP handshakes, right? Can we talk? Yes, we'll talk. How are we going to, and there's always this send, receive, this make a request, get an acknowledgement in TCP. So there's a type of attack called SYN flooding, where the rogue computer makes a request and maybe does a couple of steps in the handshake, and then the target computer sends a packet, and now it's waiting for a sync, an acknowledgement from the target, and the target never sends it. So now the computer the target keeps that connection open, waiting, Well, now you've got thousands of evil rogue computers all doing this at the same time to the target. And now it's got thousands of these open connections that it's waiting on a message, on a sync message from. And as a result, it'll use up all of its networking resources. It won't be able to accept any other connections from valid users. And often it might crash the system too. So this is one form of denial of service attack. It is interesting. There's lots of them out there. This one's interesting because it's actually happening at the TCP level, which you would think is pretty high for this type of thing. In the old days, they would often just use ping and just flood a computer with ping packets, again, from thousands of rogue machines. But I think most computers now can handle that, so they've had to go higher up the stack. This picture is just meant to show a model, and they call this attacker or infected. I would call this the attacker management node. All of these zombies are nodes that somehow they've taken over. The owner of the computer may not know they're a zombie. They may not have any idea. There's just something running in the background that they didn't put there. And then when this master computer tells them all to do it, they all start sending out these attacks at the same time. So one computer is not going to overwhelm another, but 1,000 computers can overload even a big server.
Yeah, I was reading recently about they have these toothbrushes that are internet connected.
Yes.
And they use the toothbrushes as a bunch of zombies. Well, why would worse either?
Why would you? Yes.
The internet connected toothbrush in the first place. Yeah. Like that was just a setup. Like, let's sell them. I'll buy this. Let's sell them some internet toothbrushes.
Our refrigerator wants to connect, and I'm like, no, I don't want. Why does my refrigerator need to be? That's crazy. But yeah, and those devices, right? We talked about how when you build something, security is never in mind. You just want it to work. So you're building the first internet-connected toothbrush. You just try to get it to work. You're not thinking about security, and then somebody comes along and figures out a way to abuse it. It's crazy. Okay, some other types of attack. We aren't going to get into these too much, but I did just want to mention the terms, so if you hear them down the road. This one, the first, is called on-path attack, but it's usually called man in the middle. And this is the idea, if this computer is talking to that computer, and I can somehow get in the middle and listen to both sides of the communication, I can learn something. They do this, or at least I've read, where like you'll go to a coffee shop and you think you're hooking up to that coffee shop's Wi-Fi, but you're actually hooking up to a bad guy's Wi-Fi. Right. Now he is hooked up to the coffee shop, so as you're doing things, everything works, you think it's fine, but he's sitting in the middle capturing everything you're doing. If you happen to log into your bank, maybe you can get that information. There's other ways around that, but that's an interesting one. DAuth is the idea of once you've been authorized to a Wi-Fi point, they can send fake deauthorization frames that will trigger your client to be deauthorized, so it won't be able to connect. It'll attempt to reauthorize and hopefully get to an attacker's access point rather than the one they were on before. We still use a lot of old protocols, and many of them are insecure. So I'm sure you know HTTP and HTTPS. There's lots of websites that still use HTTP. It's crazy, but they are out there, and it's very insecure. DNS poisoning or DNS spoofing, this used to be a big deal. It's not so much anymore. So if you remember DNS, there's like root servers up here at the top and then other ones down below. So if you're down here and you want to connect to Google, you send a name request to the DNS server. If it knows the Google's IP, it returns it. If it doesn't, it goes up the chain and asks until it gets an answer from some authenticated server. There wasn't a lot of security built into DNS, obviously. We've just been saying that, right? So because of that, people were able to go to some of those top level servers. Hey, come on in, man. And and change entries. So now suddenly, instead of going to Citibank, you're going to this fake site. Very dangerous. But they've hardened DNS. It doesn't have quite those same vulnerabilities. And really separate from that is this idea of backdoors. These are security flaws that were often designed or built in. For many, many years, we shipped equipment that had default passwords. So when our service techs would go on site, they could always get into the system with the default password. And these were not great passwords. They were very simple passwords usually. But that's a huge flaw because anyone who knows that now can get into the system. So that's not done anymore. All right, so shifting gears, we're going to talk about different types of malware. Malware is just any software that's bad, that's evil, that's trying to cause you problems. So the first one is a virus. A virus, what defines that and why we call it a virus is it can replicate itself. So if you get a virus on your laptop, back in the old days, it would send pop-up messages trying to get you to go somewhere, and you would just keep getting multiple pop-ups. It would just keep duplicating itself. Trojan horse is when the virus or the malware is embedded in a program that you think is good, right? So you think you're downloading a valid program, but embedded into it is some malware. And this happens on a lot of sites. I'm very careful where I download from. There's a site called Major Geeks. If I need something, I like to go there because they scan all their software. But if you just go to a random site and download an executable program, it could contain a Trojan horse. That's slightly different from a worm. A worm is designed specifically to move. So if it gets on one computer on a network, it will try to get on the other computers on the network. Now, what you often find is that you'll have a piece of malware that has pieces of all three of those. So it'll try to replicate itself. It may have came in a hidden program as a Trojan horse. So, it tries to get around on a local area network. So malware has gotten much more sophisticated. It's not just limited to one of those. We've talked about bots. That's a program that's on a user's computer that they probably don't know is there, but that someone else can control and have that bot now do something without the user's knowledge. A botnet is a collection of those. And, they can have thousands of these toothbrushes around the country that they're in control of. And then slightly different, now we're on to ransomware. This is a big problem where they come in and they encrypt all of the data on your hard drive. And then you get a pop-up that says, I've encrypted all the data on your hard drive, send me 5 Bitcoin, or you can't get back to it. But it usually just says, send me 5 Bitcoin and I'll give you the key to decrypt it. And then it sits waiting for you to enter the key. So if you don't have backups, you're in a lot of trouble if your backups have been corrupted. So ransomware is a big deal. Companies do get hit with that. Where I worked, we actually had software that prepared against this. It would take regular snapshots. So if you did get hit with ransomware, you could go back. You might lose a few days worth of data, but you don't end up having to pay the bad guys.
Well, I mean, this day and age where that's becoming a big thing, as far as the ransomware where it's becoming a big thing these days, why don't you let hospitals and stuff already have that built into their systems? I mean, it's not like it's something brand new. This has been happening for years. I mean, like I read the other day that all the water treatment plants now is being attacked. They're under attack from China or somewhere. And so why don't you already have stuff already put up for this? I mean, it doesn't make no sense. I mean, money?
It always comes down to money. And in the company's mind, it's like when you're speeding, right? I drive 285 every day. I'm not doing 55 miles an hour. But there's 1,000 other cars the cops can stop. So I'm hoping they're going to catch one of them guys. And so companies will often say, well, yes, we could be a target, But why would they pick us? They could pick this one, they're bigger, or this one, they're not as nice as us, and you just don't know. But you're absolutely right. We have fixes for a lot of this, but it can cost a significant amount of money. And technical people, you know, we like to drink beer, we're kind of lazy, and we just want it to work. Does it work? I'm done, I'm out of here. We don't worry enough about those issues. And that's really what this whole module is trying to bring to light. You need to keep in mind that these risks are out there. This is an image of one of these malware risks. And in this particular one, I think they were threatening to release the data. Oh, it says one file will be deleted. So there's a countdown timer. So you have to give them the Bitcoin or suffer some kind of loss. Okay, malware characteristics. Well, it can encrypt your data, or the malware itself may be encrypted, so malware scanners, software searching for malware, can't find it. It's often stealthy. It tries to hide in programs that are legitimate. They use this polymorphism where the code sort of moves itself all around. So if you looked at it, it doesn't even look like code, but then once it gets in a computer, then the code is moved back, and now you have the virus code ready to run. They use time dependence and logic bombs. So rather than immediately attacking your computer as soon as it gets there, it might wait a while, and it might wait till it can spread to some other computers. Lots of different ways that modern malware can use to trick, especially regular people, because regular people don't know. They're just trying to go on the web or what have you. All right, knowledge check. I'm not sure this is a good one to have here, but it's okay. Which of the following social engineering attack types most likely requires that the attacker have existing knowledge about the victim?
Phishing.
Yeah, phishing. If you're going to send them an email, it's good to know. We haven't really talked about physical stuff yet, like tailgating, shoulder surfing, as they just stand behind you. For example, when you're typing in your passwords, so look at that.
Why do the questions come up so soon?
What's that?
When we're talking about in this PowerPoint, why do they go so soon?
Yeah, that's why I don't know. I didn't put the knowledge check there. But traffic, stop it. Okay. You gotta love technology. Right, yeah. And the answer is phishing. We talked about that. It's got to appear to be a legitimate email. Okay, risk assessment and risk management. There's really two different flavors of this, if you will. They're, of course, very related. What we're talking about is computer security or computer network security risk assessment. And we're talking about threats and vulnerabilities to our network. But from a business level, from a higher perspective, they can cause business risks. And so the business may have to risk what's going to be the impact to our hospital if we get hacked. And maybe that's how they can justify spending the money, because they understand this network risk could cost the hospital some money.
It seems like to me is the amount of money they're going to have to pay one of these companies that tax them with ransomware, they're going to have to pay them more than if they just go ahead and get out to you.
Yep.
Money to put the protection for it.
Right. Often that's the case, right? So just like if you get a DUI, back when I was younger, I used to drink and drive from time to time, which is a horrible thing to do. But you're always running the risk, right? If they catch me, it's bad. But if they don't catch me, it's okay.
And also,
Yeah, I'm not going to call a taxi or Uber or something if I can just get home. So, but it's always that, and that's really in a business mindset. So drink, drive, and that's different. In a business mindset, you have to make that assessment, and you have to decide, Are we willing to take this risk, or are we going to prevent it and spend the money? Okay, so those are the two things, the two areas of risk assessment. We are going to look at a risk assessment would look at your business processes, vendor risk assessments. I've been on both sides of that, where HP was working with a company and we had to make sure that they had good security in place. And I've been on the other side where we had companies that wanted to make sure our security met their needs. So years ago there was a company, I don't know if they're still around, GE Capital. They sort of acted like a bank, but we had access to their network and they sent a guy out and he had to look and see how everything was set up. We had these little keys back then that were a digital key. We kept them in a safe. So we checked the safe and everything. So you can work with your vendors as well. And then a security audit, we talked a little bit about that, but that's where you bring in an outside company often to do a thorough audit. Because when you're sitting here, you think you've done everything. But then when you bring in somebody from the outside, they will help you. Risk management, that's the overall process of preparing for risks. That's this whole module. And these slides now we're talking about risk assessment, which is a part of that. And that's where you're going to look at a risk and say, how likely is this to happen? And if it happens, how bad will it be? So how likely am I to get stopped, and how bad will it be if I get stopped? Okay. This mouse is having trouble. That's the problem. Okay. Huh. Very interesting. So now we're going to talk about attack simulations. You can do these yourself, but generally you bring in experts to help you with these. And it's a simulation. Obviously, they're not stealing anything for real, but they are going to attempt to get into your systems. They're going to see if the attacker has some access, if they've been authenticated, how far can they get? Or if they have no access, if they're just anybody outside of your business, they're completely unauthenticated. And so those are the two types of computer networking attacks. The other one you'll often hear about, especially in cybersecurity, is penetration testing. And this is where they try to get physical access to your building. This came from the military. The military came up with this concept. As they often do in the computer world, they start a lot of things, and they came up with this idea. So the way they do it is typically you have what they call the red team and the blue team. And this model over here might be your own internal team. So you have the red team that are trying to attack, the blue team trying to make sure all your defenses are working, and then when you get together, you now become the purple team, and you look for improvements. Generally, when you bring in outside consultants, it's us versus them. It's like a game of paintball, but with computers. And they will try to sneak into your building. They'll try to do all sorts of things. And I've never done that. I'm sure it's a fun game. I have worked at some high security facilities, and especially when I was much younger, sometimes their security is very lax. So I've walked into like bank data centers, unescorted, nobody, just, the first day you go in, you sign in, you get the badge, you talk to the guy, you go. But by like the third day, you're like, I know where I'm going, and I'm in. And if I was a bad guy, I'm not a bad guy, but if I was, that would be really bad. So these companies will do this and help you find those holes that you weren't even aware of. And I'm sure it's a fun job. All right, we've talked about network scanning tools. I put some of the big ones down here. I don't know anything about all of these, but they're big tools that a big company would use. Generally, in a corporation, you want to know everything that's on your network, why it's there, and you want to make sure that changes aren't happening to it, like software is being added to it without your knowledge. So there's lots of lots of things that scanning tools can track. They often will start with sort of building a base model, a baseline of what things look like, and then they look for changes. So they're not scanning everything constantly, they're just looking for any kind of changes. We talked about Nmap. These three are listed, I think, because they're free. So you can go to the internet and download these and play with them all you want. And certainly worth. Nmap I have used, or it's now, I think the NESSUS, Nessus, is just like a GUI in front of Nmap. But it works, they both work. All right, so now on the Defender side, they came up with this idea of a honeypot, which is a decoy system. So it's not a real system. So here you have the internet, and here is your firewall protecting your company. And then outside the firewall, you've got this system sitting there that if someone didn't know, they might think that's a real system and they start to attack it. Why would you do that? Well, now you can see who's attacking you, what they're trying to do, how they're attacking you, so you can gain some insight. This used to be a big thing. I honestly don't hear much about it, but maybe the military, people like that, big companies, they probably still do that.
Maybe it's too obvious now, so I don't use this.
Maybe it is, yeah. The other thing you'll notice is that sometimes inside the actual network, right, so these are hopefully well protected, well hardened, they'll stick another little server that's just sitting there with less security on it, once again looking for someone to try to attack in there. I'll save that. I was going to make another comment, but we got a ways to go still. Oops. Okay, physical security. This is the one where I think the knowledge should have been before it. You mentioned CISA earlier. I've actually put a link down here to a nice white paper that talks about physical security if someone's really interested in this. Physical security and sneaking in is a big deal. You have to prevent it, but it's tough because people are nice, right? You're going through a door, an attractive young person comes up. Are you going to shut the door on them? Probably not, right? We're all human. So how do you do that? They talk over on this side. You have this idea if you want to be able to detect people and you want to have a response plan and you would like to have some method to delay them. So you may have multiple security points, so hopefully you can catch them before they get all the way in. There was a story years ago, and I believe it's true, lots of people have tried it, that if you carry a tool belt or tools or a hard hat or a safety vest, you can get in anywhere. And this means these guys are carrying a ladder and they snuck into the Super Bowl. Because nobody stops somebody who's working, right? You don't know what they're going to fix. It might be important. So physical security, that kind of stuff is really tricky. And right below that ladder picture, there is a link. You can go read a nice paper on it. Military bases have this problem too. Because if you're like an Air Force base and a guy comes up in an Air Force uniform, you know.
For the longest time at Fort Benning, where Columbus, Georgia, where I used to live, for the longest time, anybody could just drive on the base before 9/11.
Yeah.
You just drive on base, no problem. I mean, there was no
Yeah.
security. I mean, unless something happened specifically, there was no gate or anything. You just drive on post, go anywhere you wanted to go. I mean, anywhere.
I think one point there was that old CISA show that actually sold jackets. It looked just like the people that work at CISA.
Yes.
People wore those and got secure areas because of that.
Yes, absolutely. And so those penetration test people, that's what they'll do. They'll have a jacket that says FBI, or they'll be dressed like a professor or a senior leader. You're not going to stop a guy in a tie with fancy shoes and a Rolex. You go, that's some bigwig. I don't want to get in trouble. But it's often a problem. Okay, so these are some physical prevention methods. Have a keypad, access badge, biometrics. I've never used biometrics. I've been in places where they had them, but I never had to use them. But they do have places where they do the eye scan. They do thumbprint, and I've seen one where they did the whole hand. I don't know what it actually scanned, but it had like a picture of a hand, and you put your whole hand down, and then it would let you through. I suspect that'll become more common.
Like hand scans can be, well, maybe it's just something you see in movies, like somebody could just like put some over your hand. And,
right. I don't know if any of that's true or not. Yeah.
I just saw one in Whole Foods where you can scan your palm and use Amazon.
Wow. There you go. So, I mean, that stuff's coming, and it's going to become facial recognition. So you'll just walk into the store. It'll say, it's Jonathan. He owes us $100. He's going to get some chocolate and some bread, and yeah. But that's coming one way or the other. And then smart lockers to control access to equipment. A lot of this stuff, though, assumes that people are being good and following the rules, and that's where you get into trouble. Is the bad guys aren't following any rules. And then for detection methods, well, here we've got cameras. That's the big thing. I've been to a lot of places. I've never seen, underfloor mats like they have in the movies where they wait, I've never seen any of that. I have seen infrared where they look for infrared heat signatures, but that's a camera, so it's the same idea.
Have you seen lasers?
No, not in a real place, just in movies. Well, that doesn't mean they don't have it, right? People don't always show you all their security, but usually it's a big guy with a gun in most places. If you want real security, you get a big guy with a gun. Or maybe if you want really security, you get a little guy with a gun because he'll probably shoot you. The big guy might not, I don't know. But, okay, now we're going to talk about this zero trust model. This is relatively new, but if you think about the old days, so I have my company, I've got my servers, my storage, my employees, they all got computers. And I trust everybody because we're all in the same company. Now we're going to build a wall around our company. We're going to have a firewall around our company because we don't trust anybody who's not in our company. That's where the bad guys are. But if you're in the company, we love you, you're part of the family, you're trusted. So what happens? If a bad guy breaks in, they now have physical access. There was very little security that would stop them. If one of your employees went rogue, there was very little security to stop them. So this new model says we don't trust nobody, nothing, no-how. Everybody has to prove their identity, even the hardware. So when your computer, these brand new computers, the newer ones, when they wake up, they check that their BIOS hasn't been tampered with or changed. Then they verify that the operating system hasn't been tampered with or changed. Then they'll boot up. And then they continue to look around, and then they have to identify, like with a Windows domain server. So they identify with that server, but they also make that server prove to them that it is the right server, right? It's all this extra layer of security. Now, theoretically, it doesn't add much time, right? It's computers talking to each other. They do it real fast. For people, it might mean multi-factor authentication or, a password and a biometric, something like that. But this idea is becoming more and more, especially internally in companies, because now they don't trust anybody because they've treated people so poorly. No, that's not it. But now they realize that a lot of the trouble comes from the inside. So, but you will see more and more about this concept of zero trust. Let me see if I can find if this mouse cable is loose or something. That's part of the problem. It seems to be jumping around a lot. Well, looks like it's okay. All right, device hardening. This is again the idea of adding more security in a Windows environment. So when you default install Windows, it offers lots of services and lots of features. If you're setting up a server, maybe you don't need some of those, so you would disable them. That way someone can't sneak in through one of them and attack you. And there's all sorts of other device hardening techniques that are out there, including for routers, network routers. Updates and security patches, this is a huge deal. Most people don't like to install updates and patches, but it's absolutely essential that you keep all of your computers up to date. I don't know how they do it here. I'm sure it's a pain in the neck doing so many thousands of computers, but they're pretty good about making sure that they stay relatively up to date. Administrative credentials. So this sort of goes back to the zero trust, where how do you prove who you are? And one of the ways is we use SSH keys. Now, SSH comes from secure shell. That's sort of where it came from. But now it's expanded much beyond just the Linux shell. And these keys are, they're able to encrypt data in such a way that only the right recipient can decrypt it. So they use a pair of keys. We're not going to get too far into this, but they're able to make sure that that data can't be read by anyone other than the correct recipient. I threw this in there as some pictures are worth it. Oh, I'm sorry, secure shell keys. So secure shell keys are a pair of cryptographic keys. So basically, this computer has a public and a secret key. This computer has a public and a secret key. Well, you give each other your public keys. In fact, anybody can have your public key. It's okay. But you hang on to your private key, keep that secret. And then, for example, this guy could encrypt using his private key, send it over to this guy, and he would encrypt with this computer's public key, send it across the network, and then this guy could decrypt it with his own private key. And this is a very secure method. It's used for everything these days. So I think if you get into crypto crime or any of that, you'll probably spend a lot of time looking at that. Okay. Extra services, insecure services, and protocols should be disabled. We just mentioned that. You're trying to reduce access paths for bad actors to your system. You want to make sure you use the highest level security you can. If you can turn off processes at startup time, that's great. Disable unneeded services, remove unused software, and also streamline the network. So for some managed networks, you can actually just turn off unused ports so that even if somebody gets to your router or your switch and plugs in, they can't do anything. So just some extra security to keep in mind there. Okay, now we're going to talk about passwords. Passwords have been around forever, and there's two things we do with passwords, because the system has to store the password, right? Because it has to check the next time, but it has to store it in a way that if somebody gets access to it, they can't sneakily figure out what your password was. So the first thing is we had this secure hash algorithm. It's been around a very long time. If I recall, the differences between SHA-0, 1, 2, and 3 is the number of bits that they use. So now that's okay. Now they're up to like 128 bits. So it's a very big hash. So you're not going to be able to look at it and de-hash it, if you will. That would be for yes.
Bits are per character or bytes are per character?
Bits are per character. A byte is usually 8 bits.
Right. Bits are per character. A byte is 8 bits.
Right. Did I say something wrong?
You just process it.
Okay. And then I put an aside up here. That's driving me a little crazy now. I put an aside up here. We all have a lot of sites we have to go to. You don't want to use password 123, all that kind of stuff. Lots of people, you would be shocked at people who still use that today. But one thing that's come up recently is this idea of using a passphrase. So rather than trying to remember random words, you have a phrase in your mind, and that's usually easier for us to remember, but it's still very long. So you can make these very long. And this one here, out where it says Waffle House, for example, I don't know if you can read that, but this mouse is not cooperating. Well, all right. But one of those is the number 0, the other is a capital O, so you can do things like that. And this meets all the criteria. It's got upper and lowercase, it's got numbers, it's got a special character. So you can have a very secure password by using a passphrase. So that's a good thing to tell your mom for her bank anyway. Okay, this is the process that we're talking about for encryption, and we're not going to spend a whole lot of time going through it, but there's two different things here. When you encrypt something with an encryption key, generally you need a key to decrypt it. You have to have the right key to decrypt it. When you hash, you're really just taking like 128 random bits and then running them against the password, usually additively, something like that, and then you get this new completely scrambled gibberish. And what they're saying over here is that encryption cannot be undone, but hashing, at least theoretically, encryption you can reverse, right? Whereas hashing, you really can't. So now you come back to your computer, you type in your password again. Well, how does it check that you typed in the right thing? It runs it through the hashing algorithm again and compares the output. So it's not storing your password, it's storing the output of the hashing algorithm. So your password only exists in memory for a few milliseconds till it completes this hashing. So encryption is reversible if you want to think of it that way, whereas hashing is a one-way. It's really not possible or easy to go back. All right, anti-malware software. I'm sure most of us run some sort of software, maybe Windows Defender, Microsoft Defender. There's all sorts of malware software out there, anti-malware software out there. There used to be recommendations to use other things. Occasionally I'll run some, but in general the Microsoft stuff works today. But how do you know if you have a problem? Well, one, if you download something from a site that's not trustworthy, you should worry. If you wind up at a site and you're like, how did I get to this site? Maybe that's something to worry about. If you see files getting big or your disk space being taken up, that could be an issue. Huge performance declines. When I first got this laptop, it performed horribly. And the guy re-imaged it twice. It still performs horribly, but probably doesn't have any malware on it now. So just those kind of things you wanna keep about. And then if it accidentally, unexpectedly reboots for no reason and other things. So just be aware of those sort of issues. Anti-malware in a network environment can work many ways. You could have it on every system, like the Microsoft. You could have server or network based, where it was looking at packets and looking at things, or even cloud based that would come down and look at your things.
So which one is the best?
A combination is usually the best. You got to have everything. Trust no one and check everything. what did Ronald Reagan say? Trust but verify. But this is don't trust and verify. Okay, new topic here. Asset disposal. So, you've had a bunch of hard disks for 5 years running in an array. You're worried they're going to start failing. You buy a new, bigger, faster array. You copy all the data over to the new one. Now, what do you do with the old stuff? Well, that's a real problem. And so there are actual certifications and companies that will come in, and I've got kind of a joke there, but they will physically destroy your hard disks. And there's different ways they do it. We used to go out and we had demagnetizers, just a big electromagnet. Sometimes they'll drill through them with a drill. And other places like the government, they use one of them giant crushers. You ever seen them? They're like 2 wheels. They just drop the whole hard disk in and you get shards out the bottom. So, but this is physical protection after the fact, because if you donated them or you tried to be nice, somebody could theoretically get access to your hard disk and perhaps get access to the data on there, which might be very compromising to you or your customers or your business or what have you. So asset disposal is a big deal. In fact, here at the college, we're doing some right now with some old routers, and Dr. Walker is handling all of that. Okay, user security policies. This is always a balancing act because users always trust themselves, right? They always think they're good. And a bad user will lie to you. See, there is no win. Nobody wants to do the training. Nobody wants to go through with it. Everybody hates whatever software you load on there. But you have to have useful and manageable user security policies to protect your software and your hardware and your data. And I put this picture up because really the main thing about it is training. At my company, we had 4 trainings a year. They'd be focused on slightly different topics. Some of them were more international. Some of them were more customer focused. But just this idea of constantly keeping this fresh in people's minds. Be careful of unsolicited email. Be careful of email that doesn't look right. It's got like a special character in it or something. And regular people don't know that. Regular people, yeah.
My friend, he got a text saying that UPS had a package with different thing, and he went on there and put his whole entire card information and everything.
Wow.
And then he told me something about like, oh yeah, I'm just waiting for a package to come, something like that. And I said, I'm like, sure, all right. And I told him to give it, like, to screen share it and give it to me. And like, oh my God, no, this happened before. Like, many people have gotten their card information. Really? He didn't believe me because like when he clicked the link, it was like everything was like the exact same.
Yes.
It's just like I looked at the lettering of the website and it was off. Like everything was off. And it's not up to date. And then we checked the package number through the actual website and it said this package number is using scams. I don't trust it. So he went out to go get the card. And I don't know.
Had they charged anything?
I'm not sure about that.
Okay. I get those texts all the time. I get WhatsApp messages from people. I love the ones, so my wife's name's Renee, so I'll get, hey Renee, how are you doing? I'm not Renee and you're a scammer. So I used to say things back to them, now I just block them and move on. But
I have a question for you. Like,
Yeah.
say for instance, like these scam emails, like I say, I get a million of them.
Yep.
If you accidentally click on just the email itself, are you at risk or you have to click on something inside?
Usually you have to click on something inside, but I've heard now that some of them, they put a PDF and somehow that PDF has executable code tied with it. Because it used to be you had to click in it and they'd have like a Word or Excel or a link to a website. And all of those can infect your PC, but now anything. But yeah, no, I think you generally are safe to open it, but then just delete it or block it. I get them every day too. Everybody does. I don't know what how you prevent it. Back in my day, the scammers would call you on the phone.
See, I was out cheering King.
Now, does anybody answer their phone? I almost never.
I have to not start one.
Yeah, unless I know you, I'm not talking to you. What? It's crazy.
My phone just tells me it's a scam before I even answer it.
That's nice. That's a nice feature. So you're like, ah,
If it's important enough, you'll leave a message.
yeah.
I would say voicemail.
Yeah, sometimes.
I wouldn't say voicemail.
I think it's the old people and the undereducated, underexperienced. Those are the ones that they catch and they rip off, and that's sad. I feel bad. So years ago, when I was younger, I think I got a call from a scammer, but he was obviously Indian and he was claiming he was from Microsoft and needed this. And I said, I let him go through a spiel, and then I said, does your mother know that you're a scammer and you're trying to rob people? What would your mother think? And I'm going on and on about his mom. He hung up eventually, but I don't have the time or energy on that anymore. Hopefully it changed his life. Now do they have preachers in India? I don't know. Whatever they have over there. All right, the goals of your security is always interesting. Ensure authorized users have appropriate access. That should always be a goal. Prevent unauthorized users, right? Protect sensitive data, prevent accidental damage, prevent intentional changes or damage, create a secure working environment, communicate or train employees. In my experience, most cybersecurity professionals are only happy if every computer is powered off. Then they're very happy. They're thrilled. Are they all off? If you're trying to do work or something, oh my God, they go nuts. So I couldn't work in cybersecurity. That's a different world. It's like being a lawyer. But it is important. And at big companies, especially ones that have already had breaches, it's a big concern. This is a very interesting thing. So what about bring your own device? Now, I cannot access my email from my phone. I don't know if I could set it up or not. I haven't tried. But in many companies, they let you bring your own phone and access your corporate email from your phone. But then what they want to do is they want to manage your phone. They have these mobile device management software. So they want to install that on your phone that you paid for so they can manage your phone while you're reading email for your job. Some people are okay with that. Some people get very upset, and companies have different ways of dealing with it. Sometimes they'll give you a cheap phone that you can still use for the company. But this whole idea of bring your own device is always a fascinating discussion wherever you go. Some companies you can bring your own computer even. Now here at the school we're given laptops, but other places you bring your own laptop and you work on that. So it's a big issue. And of course the problem is if you have someone with their own phone or their own laptop, you don't know what they're doing with it outside of work. They can legally do whatever they want with it. But if it gets infected and then they bring it into the work environment, now it could infect other devices. So that's the real issue and concern around this. So at companies where it's a big deal, they do still buy people's cell phones, and the company will give you a cell phone, and then you got to carry two phones, your own and the company. But most places now, they have you use your own phone after hours, but they want to manage your phone to make sure it's not doing anything it shouldn't. So just be aware of that, because setting that up is not as easy as it sounds. And, we've talked about phones, but also if you're using your own computer, you probably need some VPN software to get into the corporate network. So now that you've got to manage the VPN software, and if you're inside the company, you got to worry about that and what else can come over that VPN link now. Because, once you open up that pipe, it's open and various things could come in that maybe never would have got into your network if that person didn't have the VPN. I think in cybersecurity at most companies, this is a big topic. Acceptable use policy. I have many stories I won't tell you on this because we're recording today, but basically, if you're given a work computer, it's crazy, use it for work. Don't go to porn sites, don't shop on Amazon, don't do anything else with it. People will do crazy things with their company laptop. Don't. Work is work. Everything else is your own. Keep it on your own stuff. I've seen people fired over this, over using their business computer, business devices for their own personal use. So just be aware of that and make sure if you're in IT, that you have a clearly documented and stated acceptable use policy. And then if you're a user, don't try to sneak around it, right? So I think I mentioned here at the school, TikTok is blocked. It's blocked on this computer. Is it blocked on the whole network?
Yes.
Okay. So that's a state of Georgia rule from the state. And so they've got it set up that way. So I'm not sure. What's that?
It should be.
Okay. But I mean, you could pick other sites that are blocked. I think there's a number, like I think Amazon is blocked as well. So there's a lot of sites that they block.
TikTok is a big problem.
Yeah, but you just can't, if you're the user, don't try to sneak around and say, well, I got to watch TikTok. I got to watch whoever, I don't know who the big, Jake Paul, is he on TikTok?
He's gonna fight them.
He's going to fight Mike Tyson.
Oh, that's what I did.
I think so. I don't know if he's on YouTube or what he is.
He's a YouTuber.
Okay.
I don't know when he actually done, but I just know he's a YouTuber.
Yeah. He's got millions of people who follow him every day. I've never heard of him.
Not my crowd.
No. Now, Mike Tyson, I've heard of. He's
my crowd.
Yeah, I remember him back when he was a very scary person.
Oh, he did buy somebody here, didn't
Yes, he did. Yeah, that's the guy. But I'd rather him bite my ear than punch me. I think he could kill you with a punch, right? That's he hit people so hard. He was great.
he? You know how bad you gotta be to buy somebody here?
Yes,
That is a different level of hate.
yes. I've never reached that, fortunately, but. Okay, so now we're going to talk about anti-malware policies. Once again, if you're in a company or an organization's IT, you've got to make sure you have a clear policy. Every computer should have some sort of detection software. You have to decide, can users alter that and change it? What do users do if something bad happens? Generally, they'll just call IT. But then you also need a team that's listening for alerts, because a lot of this software will send alerts to a central server, so somebody has to manage that. I'm sure the state of Georgia has people who do that. I'm not involved with any of that. But from the IT side, you gotta set this stuff up ahead of time to prevent problems from happening down the road. A lot of risk management happens before. So it has to happen before you have a problem. So you plan what could happen, how much is it going to cost if it does happen, how likely is it to happen, how much are we willing to spend to make sure it doesn't happen. That's really what risk management is. The other side of that is, what do you do if it happens? So in risk management, you may develop plans. If we have a major network outage, here's who you call, here's what you do. So companies will often have those plans would be developed as part of risk management. And then you should also have a after program. So we used to call it lessons learned. So when something really bad happened, when all the dust settled and everything was back up and running, then you'd say, okay, what really happened? How did it break? What can we do to make sure that particular problem doesn't happen again? So risk management is a big thing. Often in corporations, they will bring in project managers, so they're not technologists. So they will lean on you. If you're the technologist, they'll lean on you because they don't understand the technology, but they do understand the risk management processes, and in particular, they're good at ascribing a dollar value to an outage, right? So if the B building network goes out for an hour, what does that cost GPTC? Well, what if the A building network goes out for a week? What is that? So that kind of work can be tricky for technology people, and that's what they would do. Okay, here's another one of these. What kind of software can be used to secure employee-owned devices?
Mobile device management.
Right. Mobile device management, that is the software that your company will often require you to run. For a lot of people, it's okay, but for some people, it's a real issue. All right. In the summary, we're going to look at people and technology. We're going to look at internal and external. We're going to worry about our network and making sure our network is secure. We're going to put physical security in place, and we're going to harden everything we can, the hardware, the software, the network devices, to prevent bad people from stealing our data or doing something worse. Yeah.
I got a question for you. Ask your opinion on something. There's like this little, it's an app on Google Play called Google Cybersecurity University. You learn about cybersecurity and stuff, right?
Yep.
And it said that one of the things when it comes to risk management is with your personnel, which are your business risk, the having a good paying them well and giving them good benefits is part of also risk management. What do you think about that?
I 100% agree. I 100% agree. And, nowadays companies don't want to pay anybody anything. And so employees become desperate or angry and they steal and they do whatever. Slightly different analogy is the self-checkout machines, right? Companies put those in thinking they would save lots of money. We don't have to have cashiers around. And of course, people steal. It's so easy to steal. It's hard, if you're honest, it's hard to do it right. Nobody trains you. You just go up there and you gotta do it. So now I hear some companies are moving away from that. They're going to bring real cashiers back.
Yeah. Walmart's going to do it.
Yeah. Now I've known real cashiers that will steal too, but they'll steal like if their mother's coming through the line. Mom might get a discount on a couple items. That's going to happen. That's okay. But it's not like everybody's stealing. So, but yeah, people are always the biggest weakness, and if you pay them well, if you treat them well,
Yeah.
that's a huge thing. And companies today are really not doing that well, I don't think. Maybe because I'm old, but companies just aren't as good as they used to be. Hopefully I found in my life, everything's a pendulum. So it always swings too far one way, and then people get fed up, and then it swings back the other way. So hopefully right now we're too far with low pay and underpay, and you're seeing now where people are starting to get paid a little bit more. So tipping, you have to tip a server. 50 years ago, they talked about getting rid of that because it's stupid. Why do you just pay that person? They have a real job. Why am I tip? It's silly. And then, some people tip well, some people don't, and they might not get paid, so it's a mess. Okay, we have a kind of a short day today. Any other questions on this? Okay.
Oh, wait, I have a question about the hashing. Is that basically encrypting and encryption?
No. So, I don't know if I can draw this, but I'll try. Well, that was not the right button to push. Used to be a little slow here. Yeah. So, hashing is just a math formula. So remember, these are all just numbers. And so you've got some long string, that's your data. And so you've got a key, and your key is meant to be random, so it's 64 bits of something, that's your hash. And so you take this 64, the first 64 bits, you AND it or it or some way to combine it with this, and you get a result down here. And so that's your hash down here. And you can, there's a bunch of different ways to do it. Then you take the next 64 bits, you apply this same hash to it, and you get another number.
Okay.
So it's just kind of a way to do it. And then what they'll do then is they'll take the hashed data and they'll hash it again against a different code or using a different model. So you end up with just random numbers that don't mean anything. That's the goal. Encryption, on the other hand, generally involves calculus, and so you're taking your data. So maybe you're taking 64 bytes of data. Oops, it's all binary, and you're running it through some equation, and you're using a key as a seed to that equation. So you got your data plus the key, and they go into this, crazy equation that's doing all kinds of complex math to it, and you get something out the bottom. And if you have the appropriate key, which is probably not this key, it's probably a different key, so we'll call it K2, you can take this and decrypt it and get back to the original data.
Oh, I see.
So there's just two different methods. Hashing has been around for much longer because it can be done by hardware very quickly, whereas encryption is usually done in the CPU by software, and it can add some delay. But if you really worry about this, like the government, they'll hash something, then they'll encrypt it, send it over encrypted. They take all kinds of precautions. I'll look up a YouTube video that explains that better than I just did, and I'll send it out. Any other questions or comments or notes? All right, well, thank you all very much. I appreciate you coming.